Interestingly, in any acid-base reaction, the products are also acids and bases. For example, in a reaction of hydrobromic acid and water, the hydrobromic acid is the proton donor, so it's the acid, and water is the proton acceptor, so it's the base. The products of the reaction are a bromide ion and a hydronium ion. If the reaction were to go in reverse, hydronium would donate a proton to bromide to form water and hydrobromic acid, making hydronium the acid and bromide the base for that reaction. And that's why we can classify the products of an acid-base reaction also as acids and bases. We call these products conjugate acids and conjugate bases. If we compare the formulas for water and hydronium, they only differ by one proton. And if we look at hydrobromic acid and bromide, we see that they also only differ by one proton. We call these pairs conjugate acid-base pairs, because within each pair, one species would act as an acid and one would act as a base. Hydrobromic acid is a strong acid, so let's determine the strength of its conjugate base. If bromide was a strong or even a weak conjugate base, then it would react with hydronium to form hydrobromic acid and water, reversing what hydrobromic acid just did. However, we know that a strong acid remains almost fully in its conjugate base form. This means that bromide must be much weaker than a weak base. In fact, it is a terrible base. We can generalize this for all strong acids and bases. Their conjugates must always be terrible acids and bases. Ammonia is a weak base and reacts with water to form an ammonium ion and a hydroxide ion. In this reaction, water and hydroxide differ only by one proton, so they are conjugates, and ammonia and ammonium ion also only differ by the presence of one proton, so they are also a conjugate pair. Since ammonia is a base, its conjugate pair ammonium ion will be a conjugate acid, and since water is acting as an acid in this reaction, its conjugate hydroxide will be a conjugate base. Now, let's determine the strength of the conjugate acid of ammonia. Ammonia is a weak base, so it partly reacts with water. Some of it turns to ammonium ion, but a significant amount remains as ammonia. For this to happen, its conjugate acid must also be weak. When ammonium ion is produced, some of it will react with hydroxide ion to reform ammonia, but some of it will remain as an ammonium ion. Had the conjugate acid been strong, then the final solution would only contain ammonia and no ammonium ion, which we know is not true. And had the conjugate acid been a terrible acid, then it would not react with hydroxide at all to reform ammonia, and all of the ammonia would turn to the ammonium ion, which we also know is not what happens for a weak base. Therefore, any weak acid or base will always have a weak conjugate acid or base.